Now let's resume back to the rest of the problem. We have already determined the value of H. I will draw the problem again for your convenience. We have already determined the value of effective overburden pressure of sigma V1, sigma V2, and the corresponding lateral earth pressure P1, P2. Okay. This is the groundwater table from the existing ground level to 3 feet, and this is 10 feet. So we have our earth pressure diagram up to this. This is P1, this is P2, and since the stratification of the soil layer occurred, so pressure diagram also changed at this point. Okay, P1 was 115.5 psf and P2 was 281.75 psf and P3 was 201.25 psf, which is we have determined, as we can see. Now I would like to remind the lesson that we are determining the embedded length of the cantilever sheet pile, which is this height. This is the embedment length of the cantilever sheet pile. Let's take this as D. So to determine this, we have to determine the value of the total earth pressure diagram. We have to complete the total earth pressure diagram, and we have to determine the earth pressure diagram of this region. Okay. We were determining the embedded length of the cantilever sheet pile in the conventional method. As I have discussed earlier, there are two methods of determining the embedded length of sheet pile: simplified method and conventional method. We are doing it in conventional method. So before proceeding, what happens in cantilever sheet pile? This is the unsupported length, as I have discussed already in the class in details, and this is the embedment length. So what happens when starting we are doing this for the granular soil? So when the active thrust from these regions happen, it tries to deflect the sheet pile like this, and sheet pile rotates like this from its initial position, and after reaching this region, passive thrust begins. Active thrust tries to move the cantilever sheet pile away from its position, and passive thrust from this region try to move it back towards its initial position. So at this point, somewhat this region, let's take this height as H. Here active earth pressure is equals to passive earth pressure. This is a very important equation because this equation will lead us to our solution. and using this equation we will find out the length h. What is the length h? Where active thrust is equals to passive thrust. That means this is like a hinge. What will happen? It will try to, the sheet pile will try to rotate to this point. Active thrust will try to move it away from its initial position, and passive thrust will again try to move it back to towards its initial position. And after this point H, again active thrust from this zone will overcome the active thrust from this zone, so it will try to move it away from its initial position again, like this. Okay, now at some point the passive thrust of this region again move it back to its initial position. So this is the mechanism. I have tried to simplify this for making you understand easily. So this is the mechanism for determining the embedded length of sheet pile in conventional method. Okay, so let's draw the picture again. So we have our earth pressure diagram up to this. The mechanism I have already made you understand. So you have already guessed that the earth pressure diagram will be somewhat like this. Okay, then we will have to determine the height of the earth pressure diagram, the height of this to complete whole the earth pressure diagram. So to determine the height h, we have already determined the height h equals to 0.81 feet with the equation active earth pressure is equals to passive earth pressure. Now in conventional method, the earth pressure diagram will be somewhat like this. As I have already discussed that at this point again active earth pressure will be equals to passive earth pressure. But for the simplification, I would like to draw it. The red hatched area is just imaginary. The black one is the actual earth pressure diagram. Okay. Okay. Now we can use the equilateral triangle equation for determining the value of P4. So what is P4? This is P4. Okay. Now, so as we can see, we have already determined the value of P3. So we can write we can write it as P3 by H equals to P4 by D. Okay, let's take this rest of the embedment length as D. So D equals to H plus D. We have already determined this H, which is 0.81 feet. We have to find the rest of the unsupported length. Okay, now P4 is equals P3 by H into D. So we have already determined the value of P3, which is 201.25 into D divided by 0.81. So that sums up 248.46 D. P4 is equals to 248.46 D. Let's take it as a equation 1. Okay. Now we will determine the overburden pressure. Let's take the green color for your understanding. At this level and at this level. Okay, let's take it as 0.3 and 0.4. That was 0.2 and that was 0.1. Okay, at this level 0.3, the effective overburden pressure sigma V3, and at level 0.4 effective overburden pressure is sigma V4. Okay, now what sigma V3, to determine the value of sigma V3, which is the effective overburden pressure from this dredge line up to the end of the up to the base of the sheet pile, and sigma V4 is the effective overburden pressure from initial point of this to up to this. So let's try to figure out how to find out the value of sigma V4. Okay, now back. Okay, now sigma V4 is equals to sigma V2 up to this point, which is sigma V2 plus D plus 0.81 into 115 minus 62.5. So what is the value of sigma V2? Is 805 plus D plus 0.81 into 115 minus 62.5. So that sums up 847.5 plus 52.5 D is sigma V4. Okay. Okay. Now we will try to figure out the value of P5. Okay, so as I have already discussed the mechanism, what I have told you that at this point the passive thrust from this zone is equals to active thrust of this zone, right? So to determine the value of P5, this is the value of P5, what we can do, we can substitute the value of this passive zone minus of this active zone. Okay, so we can write it as Sorry. Okay. um so P5 will be equals to sigma V4 Kp2 minus sigma V3 into Ka2. Okay, so sigma V4, we have already determined the value 847.5 plus 52.5 D into what is the value of Kp2 is 5 minus sigma V3 is 0.81 plus D into 115 minus 62.5 into value of Ka2 is 0.25. So that leads to a equation 249.4 D. This is the equation of, let's take this as equation 2. Now we have already determined all the values of earth pressure diagram. Sorry, P1, P2, P3, P4 and P5. Now what we will have to determine the horizontal force. What is horizontal force? You have already know this is written in terms of pressure area. So to determine the pressure horizontal force, we have to determine the pressure area. So we can segment. So I would like to clearly again draw the earth pressure diagram. Let's see. This. Okay. This is the earth pressure diagram. This is P1. This is P2. This is P3. And this one is this one, sorry, it's already out of this video, P4. And this one is P5. Okay, now we can divide it as this triangle, now this rectangle, this triangle, this rectangle. Okay, now this small triangle again. Okay, now this small triangle again. Okay, now this big head triangle again, and this one. What we will do, as I have already determined the value of P4, what we can do, we can subtract this side from this. So ultimately this only this portion we will take. Okay, now the horizontal force of corresponding earth pressure, we can write it as H1, H2, then H3, H4 and H5. Okay, you can determine the value as I've told you earlier, H1, H2, H3, H4, H5, sorry, H4, H2, this one is H3, this one is H4, this one is H5, and this one is H6. You can find out the value of H1, H2 since this is the pressure area. So what is the value of H1? Half into P1 into height H. So that sums of half into 115.5 into 3. So 173.25 pound. The similar way H2 is equals to 115.5 into 10, which sums of 115 pound. H3 is equals to half into 281.75 minus 115.5 into 10, 831.25 pound. H4 is half into 0.81 into 201.25 equals 81.5 pound. H5 is equals half into D into 248.46 D is equals to 124.23. Okay, 123 point 123, sorry, 124.23 T square. Okay, now we will determine the value of horizontal force at point 6, which is noted as H6. What we will do here is we have already determined the value of P5. Okay, so this is the redundant area, this green hatched one, but to determine the value of H5 we already took the whole this triangle. So what we will do for determining H6, we will take this whole triangle and we will subtract this portion from H6 to minus H5. When we will subtract H6 to H5, this portion will be removed. So determine the value H6, we will do half into half into this triangle. Okay, the green hatched one, this triangle. Okay, let's take the height of this triangle as F. So half into F into 248.46 D plus 4227 plus 249.4 D. We have already determined this as P5. Okay, now this leads to another equation of 248.93 df plus 2113.5 f. So H6 equals to this. Okay, now we already know that this cantilever sheet pile is in its equilibrium position. So to satisfy the requirements of static equilibrium, sum of the forces in horizontal direction must be 0. So all the forces we have taken as H1, H2, H3, H4, H5, H6, summation of this total horizontal force must be 0. So okay, now summation of Fy is equals to 0. Okay, then we can write it as 173.25 plus 155 plus 831.25 plus 81.5 minus 124.23 d square plus 248.93 df plus 2113.5 f equals to must be 0 for the static equilibrium. Okay, now minus 2241. Okay, after calculating this we will get an equation something like this. So F will be equals to 124.3 d square minus 2241 divided by 2113.5 plus 248.93 d. Okay, you can simplify this or you can put it this just like this, it's up to you. Okay, now here is an equation of equation 3. So there is two unknown, which is f and d, and there is only one equation. We need to determine another equation. So two unknown and two equation, then we can find out the value of f and d. Okay, what we can do is, let's go back to the problem again. We can take moment at this point, we can take moment at this point O and check the sum of the moment is equals to 0, and as it must be. So we will take moment at point MO. Okay, okay, so we have already determined all the values of horizontal forces, H1, H2, H3, H4, H5 and H6, and we will take the moment of these horizontal forces at point O. Okay, okay, so we will have to determine the values of lever arms of these horizontal forces from this point O. What is lever arms? So determine the values of lever arm. We can go to this problem again. Okay, okay, okay. Now the values of lever arm of these horizontal forces is M1 of corresponding horizontal forces of H1 will be D plus 0.81 plus 10 plus. We have up to this. Now 1/3 of total height, so that sums up to the 181 plus d. And the same way we can find the value of all the horizontal forces, lever arm of the all horizontal forces, as m2 is d plus 5.81, m3 is d plus 4.14, m4 is d plus 2/3 of the total height, as in d plus 0.54, m5 is equals to d by 3, and last of all m6 is 1/3 of m3. Okay, now we will take the moment at O. I am taking clockwise as a positive direction. Okay, now 173.25 into 181 plus d plus 155 into d plus 5.81 plus 83.25 into d plus 4.14. Okay, plus 81.5 into d plus 0.54 minus, as this is the anti-clockwise direction, d square to d by 3. Now 248.93 plus df plus 2113.5f into f by 3 equals to 0. So after solving this, you will get a big equation of d to the power 5 something, and after putting the equation in the calculator, so this equation will be taken as equation 4. You will solve the equation 3 and 4 and you will get d equals 10.11 feet. Okay, now for the safety purpose, what we will do, the big D is d plus h, so d is determined as 10.11 plus 0.81 feet. So the embedded length of the cantilever sheet pile is 10.92 feet. What we usually do for the safety purpose, as we all know, soil, the behavior of the soil is very uncertain, and the stratification of the soil layer occurs, and a change in groundwater table makes it more vulnerable. So we provide 15 to 20% more embedded length for ensuring safety. This 15 to 20% addition of the embedded length of the cantilever sheet pile increases the factor of safety to 1.5 to 2. So we will increase the embedded length 15 to 20% more. So let's provide the what we have already determined, 10.92%. Let's increase it to 20%. You can take any value 15 to 20%, 10.92 feet. So that sums up 13.1 feet. You can round it as 13 feet since you have increased it to 20%. Okay, now this is the total embedment length of the cantilever sheet pile. So if in the question total length of sheet pile is asked, then total length will be 3 plus 10 plus 13 feet, which leads to 26 feet. So this is the problem of determining the value of cantilever sheet pile. If you have any question, you can put it in your Google Classroom, or you can ask me in the next class. Thank you.